So again, this is not 8.3 yet. This is just to get your brain in the right direction for reciprocal functions. We're actually going to start this section tomorrow. What I want you guys to do is to go to Desmos and type in the function y equals 1 over x. Okay, y equals 1 over x. Y equals 1 over x. 1 divided by x. Oh, let me zoom in on that. There you go. Y equals 1 over x. Type that into Desmos. So if you graph this on Desmos, you should see this right here, which is a weird looking graph. These are called hyperbolas. We're going to get comfortable with these, kind of like we got comfortable with parabolas. Before doing anything to this, how about we pinch our screen and zoom in a little, because as you can see right here, the units are by 1 or by 2, 2, 4, 8, or 2, 4, 6, 8, 10. If you zoom in a little, you'll be able to zoom in to get them by single units. This is what I mean, right? So I zoomed in, and now it's 1, 2, 3, as opposed to 2, 4, 6. Yay? Okay. Anyway, I also want to just show you how you would graph this by hand. So by hand, I know you guys probably don't even want to hear this, but by hand, if you went for an input-output table and you plugged in a number like the number -4, when you plug in -4, you're going to have 1 over -4, which is -1/4. And then you could plug in like the number -2. If you do plug in -2 down here, it'll be the fraction -1/2. If you plug in 0, if you plug in 0 right there, what happens? What's 1 divided by 0? It's not 0, it's actually undefined, right? Whenever you have 0 in the denominator, it messes things up. If you take a calculator and do 1 divided by 0, it's going to say error. That's because it's undefined. Okay? So if we were to think, well, what about a -1? Let's see what happens with -1. Plug in -1, what do you actually end up with? -1. Okay? So you could plug in -4, you could even plug in -3, that would be -1/3. Plug in -2, that gives you -1/2. Plug in -1, it gives you -1. But then when you get to 0, something crazy happens. But what happens in between 0 and -1? What is the value between 0 and -1? -0.5 or -1/2, right? So you could actually plug in a -1/2. And when you plug in a -1/2 down here, that's really going to be 1 divided by -1/2, which is really 1 divided by -1/2, which is really 1 times the reciprocal -2 over 1, which is just -2, which gives you -2. So for the input -1/2, you get the output -2, right? So let's just take a look at this part of the graph with the coordinates -4, -1/4, -2, -1/2, -1, -1, and -1/2, -2. So when we look at that, over here, the first coordinate, -4, -1/4, you go out to -4, and it's only 1/4 of the way down, right? But then you go -2 and -1/2, -2, and then you're halfway down, right? And then -1, 1, -1, 1, -1. And then you go -1/2 and then -2. So -1/2, which is right here, and then -2, which is right there, right? So as you can see, going to the left, it infinitely approaches the x-axis. Going to the right, it infinitely approaches the y-axis. Now, we've already done these types of graphs before where we have a graph infinitely approaching a certain value. Those are called asymptotes. You guys remember that? No? Anyway, I hope you do. On this xy table, all we did were plug in negative x values. If we started plugging in positive x values, we'd end up with this part of the graph over here. Okay. Anyway, the fact is, we do have some asymptotes. I'm sorry about that. The x-axis in this case is an asymptote. Instead of calling it the x-axis, let's actually give it the equation name of a horizontal line, which would be y equals 0. Okay. And you also have a vertical asymptote, which is the y-axis, but instead of calling it the y-axis as the asymptote, let's write it as an equation, x equals 0. So do we understand that the graph is infinitely approaching this green asymptote? And as you're going to the right, it infinitely approaches the yellow asymptote? Yeah? Okay, cool. So this is what we call a parent graph of hyperbolas. A hyperbola looks like this. It kind of looks like two weird-looking parabolas opposite of each other. Okay, and of course, you guys already have this graph. We didn't have to go by hand, but I just wanted to explain inputs and outputs as we go. What do you guys say is the domain of this guy? What's the domain? X equals all real numbers, but what? But the x value cannot be what? Cannot be 0. That's right. Okay. What about the range? The range of your y values. The y could be all real numbers, but your y cannot be 0 as well. Okay. So this graph, even though it looks like two separate graphs, it's actually the same graph. Okay, it's actually the same graph. Okay. So as it does go to the left forever, and it does go to the right forever. Okay. The only value it does not exist at is the value that would make it undefined, which would be the x value of 0 in this case. And also, the other asymptote that it does not exist at, it would be the y value of 0. Okay. Anywho, what else could we say about this? Any questions on this? No? Yes. So that was a good question. The question was why are the x-axis and y-axis switched up? Because this is usually the x-axis. It's still the x-axis, all right? This is still x-axis running from left to right. And the one that goes up and down, that's still the y-axis. The y-axis still is going up and down. But the equation of the x-axis itself is y equals 0, right? So for example, what if your horizontal line were this line down here? What line is that red dotted line? That's the equation y equals -3, right? So yeah, I know that's kind of confusing, but I just wanted to show you asymptotes, and the asymptotes are where your graph ends up infinitely approaching but never actually touching. So yes, you could say that this green line right here, y equals 0, you could call it the x-axis because the x-axis is the horizontal line y equals 0. This y-axis is still the y-axis, but you could also call it x equals 0 because that's how to make a vertical line crossing the x-axis at 0. So x equals 0 is the equation of that vertical line. I hope that helps. So our goal is to get as comfortable as possible with these types of graphs. I would like you to compare the original parent graph, y equals 1 over x, which I hope you already typed in on Desmos, right? Y equals 1 over x, and compare that with these other two. Now, not these specific ones, but like this guy right here, I put a +1. I took the same exact graph, y equals 1 over x, and I put a +1 on it, right? I want you to do that. And then maybe instead of a +1, put a +2. Maybe instead of +2, put a +3, a +5. Maybe a -1 instead of a +1. So do all this, play with Desmos right now, and keep adding or subtracting values out here that are separate from the actual fraction. And then you could conclude certain things, all right? And then go back to the original parent graph, which is this guy right here. And instead of putting a +1 or a -1 out here at the side, go ahead and put a +1 in the denominator with the x. And then see what changes there, okay? So the assignment for today, and this is the assignment for today, is to, at this point, mess with Desmos, compare this parent graph with these other ones, and see how it's changing. And the assignment for today is to go to Google Classroom and actually write your response, how a number out here would affect the parent graph, how a number down here will affect the parent graph, okay? Now, before I let you guys go on that, I want to relate this to what we've already known in the past, like graphing parabolas. So everybody, we already know, you don't have to type this in, you could just watch. This is stuff that we should know from semester 1. We already know the parent graph of a parabola, y equals x squared, right? And we know that the vertex is at 0, 0, you get a nice perfect parabola. And we need to be able to look at this and be able to see how this actually changes, what this -2 will do to this parabola, what this -1 at the end will do to this parabola. And once you're able to remember how to describe that, then you'll be able to look at our current task at hand and describe how the changes when you add 1 at the end or when you have a plus 1 in the denominator with x, you'll be able to see those changes. So this guy right here, let me actually zoom in. What will happen to the parent graph, this parabola, what will happen if I put a negative sign in front of it? It reflects over the x-axis, so it's now opening down, right? And then what is this guy? Do you guys remember what that is? That's your h value. Good job. So this guy right here is your h, and this guy right here is what? K. Your k, that's right. And you know what? How about that negative sign? What was that technically? That's your a value, right? The a value in this case is -1. So you guys do remember this stuff. That's awesome. And knowing the a, the h, and the k, you'll be able to recognize which is the correct graph if it were on multiple choice, because you know that the negative sign makes it open down, and we know that the h, you think opposite on h, and we also know that h is always with x, but you got to think opposite on it. So that ends up giving us a shift where? 2 to the right. That's correct. That's 2 units to the right. And the -1 is the k value. That shifts it where? 1 unit down. So let me go 2 to the right, 1 down. Here's my new vertex. We know it's opening down, so that's just the sketch. But the goal here is for you guys to do this type of transformation in your head from the original parent graph of y equals 1 over x to maybe a y equals 1 over x plus 1, or maybe a y equals 1 over x minus 1, or maybe a y equals 1 over x with a plus 1 down here. So once you mess with Desmos, I'll explain it in a bit, but I want to pause this right now and give you guys time to mess with that Desmos, to talk to each other, try to come up with some conclusions of how it changes when certain numbers change. And I do want you guys to talk about it and then post a response on Google Classroom stating, well, if I put a plus 1 out here, this is what happens. If I put a plus 1 in the denominator with x, this is what happens. It might shift 1 unit to the left, maybe 1 unit up. So you got to play with Desmos, see the changes, talk to a partner, and then post how it actually changes, all right? And that's your assignment for today. I want to pause it right here, and maybe in about 10 minutes after you guys talk and gather your thoughts, then I'll go through the actual step-by-step explanation, and hopefully we could all understand how 8.3 is going to be tomorrow. So I want to pause it right now, work on Desmos, and we'll start it up in a bit. So let's take a look at, I graphed both right here on Desmos, y equals 1 over x, and then I simply put a plus 1 at the end. So the red one is the parent graph, the blue one has the plus 1 at the end. So when you compare the red one to the blue one, well, the red one had the asymptotes right here, the x-axis, and right here, the y-axis. That's the red one. Now the blue one has a new asymptote, which is up here, but it's still the same y-axis asymptote. So what happened from this red one to this new blue one? And if looking at both confuses you, then just compare one part of it. What happened to this red graph to the blue graph? What happened? It got shifted up 1, right? So what if I were to go back and instead of putting a plus 1 right here, what if I changed it to a minus 1? What would happen to the red graph? It would go shift 1 down. That's exactly what we see right here. The blue one's now shifted 1 down. So this red one that was infinitely approaching the x-axis is now infinitely approaching this asymptote of y equals -1. Does that make sense? Okay. So what would happen if I were to change this -1, this blue graph, from a -1 out here at the end to a -3? What would happen? If I change the -1 at the end of the fraction, change to a -3, what would happen? It would shift down 3. That's exactly what we see here. The red one is the parent graph. The blue one got shifted down 3 units. Look, the asymptote was up here at the line y equals 0, and now it's down here at y equals -3. This is your new asymptote right here. So this blue graph will infinitely approach -3, but it'll never actually touch it or cross it, okay? So do we see how this outside value is affecting the graph? It's shifting it up and down, right? What if I were to change this -3 to a +4? What would happen? Up 4. Check it out. The red one is going to now shift up 4. There it is. I know it looks kind of weird, but the red one had the asymptote right here at the y equals 0, and now it's up here at y equals +4. It's infinitely approaching y equals +4, never actually touching. But again, the number that you're adding or subtracting out here only affects the shift up and down. Now back in parabolas, what would affect the shift up and down? The k value. So what we need to conclude, what I wanted you to conclude here, was that the number at the end that you add or subtract is technically your k value. Okay? So the number that you're adding or subtracting is technically your k value, which causes an up or down shift. Okay? And of course we have a fraction right here. Now let's jump to that other one. Here's a parent graph once again, but I want to put an x plus 1 in the denominator. Okay? So here it is. The parent graph is in red, and the new graph, 1 over x plus 1, is in blue. And notice that it's not shifting up or down anymore. The up or down shift, that's the k value, and the k value is what you're adding or subtracting to the fraction itself. Now we have some number that's being added or subtracted with x, right? And that causes a shift. In this case, it shifted how many units where? 1 unit to the left. So the red graph got shifted 1 unit to the left. The red graph originally was infinitely approaching the y-axis, but now the blue graph infinitely approaches this new vertical asymptote at y equals -1. Okay? So anytime you have a number being added or subtracted to x, that's going to cause a left or right shift. Like what if I were to change this +1 right here to a +3, x plus 3? What would happen? 3 to the left, right? There it is. So I changed it to a +3. It caused the blue graph to shift 3 units to the left. What I mean by the original asymptote was the y-axis, but now you're at -1, -2, -3. Here's your new asymptote. This blue line will infinitely approach y equals -3. It'll never actually touch it, but it'll infinitely approach it. Okay? So what if I were to change this? Let me just change it. Change to a -2. If I change it to a -2, it shifts 2 to the right. Okay? So the asymptote's now at the x value of 2. So what are we concluding here? What used to shift parabolas left or right? What? The k value or the h value, right? Okay. So it's the same deal here. The h shifts left, right, and you have to think opposite. Think opposite of what you see. The k value shifts up or down, and of course, take it for what it is. Don't change signs. Take it for what it is. I don't even know why I wrote that down. Anyway, that's the conclusion, guys, that when we're looking at these hyperbolas, your equation is y equals, now you're going to have a fraction, 1 over x, but if you actually have a number that's being added or subtracted right here with x, so what is that value? Is that the h or the k? That's a h, so we're going to have x minus h. Now, why did I put minus h? Because you always think opposite of what you see, okay? And the number that's being added or subtracted outside at the very end, that's your k value. So this is ultimately what we need to understand for tomorrow's lesson. And before, when we had parabolas, we used to have a number out in the front. That was the a value. If it were positive, the parabola would open up. If it were negative, the value would open down, right? If I did have a -1 right here, then technically this numerator could be a -1. I mean, you could put a negative here or a negative there. So you could technically have an a value. This is tomorrow's lesson already. The a value could be right here in the front, or the a value could also be up here. Instead of 1 up there, you could put the a up there. Okay, so this is the new form that we need to get comfortable with, and I hope this kind of gets your brain in the right direction. Any questions? I want to take this a step further. Let's say I had, this is actually tomorrow's lesson, but might as well throw it out there right now. What if I had y equals 1 over x, let's say minus 2. And you know what? Let's change this denominator. And don't even graph it on Desmos yet. Let's put a x minus 1. Okay, just by looking at this guy, all right, just by looking at it, I know my h and my k. What's my h? +1. Think opposite on h, think opposite of this guy. And the k value, take it for what it is. So believe it or not, the h is +1, which is technically your vertical asymptote. Okay? So if you go to +1, here's your vertical asymptote. I know this is really ugly, I apologize. And the k value is what? -2. That causes a shift 2 units down. So your vertical asymptote will be at -2 on the y. So those are your 2 asymptotes. Now, is this a positive fraction or a negative fraction? It's positive, so I know that it's going to have the same type of end behavior, which is going to be like this and like this. Does that make sense? So I've graphed it without using Desmos. If you actually were to go to Desmos and graph it right now, you'll see that this is very accurate, right? It's not going to cross through quadrant 2. It's only right here and right there, okay? And it's based off of the asymptotes, and the asymptotes actually come from your h value and your k value. And just like before, the h value is always being subtracted from x, and the k value is always being added or subtracted at the very end all by itself, okay? So this is all relatable to what we learned back when we did parabolas and other graphs. By the way, what is the a value here? A value is 1. So that causes the graph to be down here and up here. Now, what if this a value would have been a negative? Like, what if I had an actual negative sign in front or up there on top? That would cause a reflection over the x-axis, which would cause this guy to now be up here and cause this guy to be down there. Does that make sense? Okay, to make more sense of that, like let's say the a value, let's go to Desmos. Okay guys, so if you go back to the parent graph, you end up with this, but if you put a negative right in front of it, it causes a reflection over the x-axis, right? So let me actually show both. I don't want to do them on the same screen because then it gets kind of confusing. But if you look at the original, it was down here, and if you reflect over the x-axis, it's going to be up here. That's why it's up here now. Okay. So this is way more than what we're supposed to learn today. Today I just wanted you to discover on your own the h and the k shifts. The h is always with x. You always think opposite of what you see, and that causes a shift left to right. The k value is always the number being added or subtracted at the very end. That causes a shift up or down.